Hi, my name is Emily Benson-Tyler, and today I'll be talking about how I created a novel scoring system to personalize bilingual aphasia therapy in my project, analyzing sentence content and nature of paragrammatic errors in treatment of bilingual aphasia patients. First, to start off, what exactly is aphasia? Aphasia is a language disorder that typically affects the left hemisphere of the brain and is usually acquired suddenly in a stroke or traumatic brain injury. Individuals with aphasia are often characterized as being able to understand what they're hearing, but unable to verbally express their thoughts. When those with aphasia do speak, words and sentences are often out of order, mispronounced, and at times do not make sense. There are also different types of aphasia. Wernicke's aphasia is typically drawn out and longer sentences that are out of order, and in Broca's aphasia, sentences are usually short and choppy. Bilinguals, making up more than half the world's population, are commonly affected in both languages by aphasia. Despite this, there is a lack of resources and literature regarding bilingual aphasia compared to monolingual aphasia. In the US, nearly 13% of the whole population speaks Spanish, and there are more than 45,000 new cases of bilingual aphasia a year, increasing because of the increased number of strokes. Previous studies have investigated specific sentence structures in English speakers, but paragrammatism with consideration to typical Spanish and English grammatical errors is relatively unexplored. Reliable research on Spanish and English bilingual aphasia is essential to the United States' growing Spanish-speaking population. This study aimed to answer the following questions. 1. What does sentence content look like in bilingual aphasia patients throughout treatment? 2. What is the nature of errors that patients make? And 3. How do they change over time? It was hypothesized that aphasia errors will decrease over the course of treatment, but bilingual errors would remain the same. As patients were only being treated for their aphasia and not taking any English grammatical lessons, the predicted bilingual errors would be the same. Sentence production data available from 15 bilingual individuals with aphasia was collected as part of an ongoing randomized control trial in the Boston University Research Lab. During the sentence production task, each patient provided a sentence for an English noun presented by the clinician. Sentences were produced across 20 two-hour treatment sessions, in which up to 15 randomized words were used as prompts. One set of 15 randomized words was kept the same for each patient throughout the treatment period. Responses were analyzed for presence of aphasia-induced grammatical errors or bilingualism-induced errors. Here's an example of the scoring criteria for one sentence. For both aphasia and bilingualism-induced errors, they were counted on a score from 0 to 5. For aphasia, errors were classified into 5 categories as denoted by Butterworth and Howard. The 5 categories were open class lexical errors, closed class lexical errors, inflectional affix errors, constructional errors, and 5 as other. Common mistakes often denoted as this last category were aphasia-induced word swaps and neologism, when individuals either say a related word similar to the target word or create a new one that isn't English. For example, this sentence receives a 2 out of 5 on the aphasia error calculation because the words are out of order and the word surface is said incorrectly. For BE, or bilingualism-induced errors, it received a 1 out of 5 because of the incorrect subject-verb agreement. The 5 error categories for BE were Spanish influence, subject-verb agreement, article error, preposition error, and other. Word count, sentence content, sentence completion, and sentence complexity were also recorded. If an error fit in both an aphasia and bilingual category, they were counted in both. Each sentence was recorded for the presence of errors and individual statistics about both of them. Data from all 15 patients with each sentence was compiled to an Excel file and then uploaded to RStudio. RStudio was then used for statistical computing and analysis related to how different factors changed over the course of treatment and their relevance. For analysis, I used RStudio, a proportions test, an ANOVA regression model, and a mixed effects model. This controlled for by-word and by-patient variation, which is natural from word to word and from patient to patient. Here's a photo of some of the code that I used as part of RStudio to complete the graphs as well as the statistical analysis. The 2 main results were most important. Here we have shown AE total over treatment and BE total over treatment. On the left, it's important to note that as treatment time goes on, the AE total, or total number of aphasia-related errors, decreased over time. On the right, BE total over treatment remains about the same, as the results were scattered throughout treatment time. Here are the collective graphs of AE total over time for each individual patient. Here's the same for the BE total over time for each individual patient. As you can see, it is more scattered in the BE individual. In addition to calculating the aphasia errors and the bilingual errors, the word count over time was also collected. However, this had an insignificant p-value. Results showed that as time went on, patients had more and more complete sentences, which is statistically significant. However, sentence content had no specific relations. Now, why are these results so important? While also confirming the treatment's proficiency in treating aphasia, results confirm that this study's separate content analysis of specific sentence errors is an accurate way of separating aphasia errors and bilingual errors. Because the aphasia errors decreased over treatment time and bilingual errors remained the same, this matched our hypothesis. It would be expected that aphasia errors decrease over time. However, because their Spanish and English abilities are remaining the same, the bilingual errors should be remaining stable. The differences in these two charts are very important because they indicate that the separation of aphasia errors and bilingual errors as created in this study using the novel scoring system was an effective way of separating them. Sentence completion results also reveal that the larger ongoing study is a reliable source of aphasia treatment and can be relied on. This is because as aphasia treatment went on, the sentences became more and more complete. This study may also provide a specific scoring system for Spanish and English bilingual aphasia treatment, and also may reveal patterns about sentence content over treatment time. In the future research, I'd like to expand my dataset to over 50 plus subjects, as well as look at grammatical factors in relation to each type of aphasia. I'd also like to investigate word count and how it's different in Wernicke's versus Broca's aphasia, which may have affected this study. How can the scoring system become more accurate? I'd also like to relate sentence structure and errors to other bilingual aphasia factors. Because I only looked at aphasia errors and bilingual errors, I'd also like to look at how the age of acquisition, the language 1 versus language 2, and the stroke type, and how they affect language proficiency. Finally, in the future, it would also be beneficial to add a scoring system to a machine learning type system to personalize and account for each patient's language history and stroke type. Here's my bibliography. And here's my final slide. Thank you for watching.